Okay, my AB kids, here we are at section 5.7. It's the last section before we test it up. We still have a few more sections after this for Unit 5, but it's the last one mid-unit before our test. So I want to give you an overview of what we've talked about so far, and then take you to what we're going to look at today. So we took a problem like this. This was our function g of x. In the first section, we were just talking about rates of change and such. The second section is where we kind of got into a momentum with these functions and how to be able to graph it and what parts of the graph are important and such. So we talked about critical points. Critical points are where the first derivative equals 0 or it's undefined. So we talked about how to find those. And then in the second section, in the third section actually, 5.3, we talked about how to determine if the function was increasing or decreasing based off of that first derivative. So you find the critical points, you make a sign chart out of it. Where the sign chart's positive, it's increasing. Where the sign chart is negative, I'm talking about the first derivative sign chart. Maybe I should note that right here, that we're talking about the first derivative. That where that first derivative is positive, it's increasing. Where it's negative, it's decreasing. That was section 5.3. Section 5.4 was, okay, well, from that, determine where you have maximums and minimums. Well, maximum happens when it's going to increase and then decrease, and a minimum happens when it's decreasing and then increasing. So that was section 5.4. Take your sign chart, determine where you've got maximums and minimums. Section 5.5 was similar, but it was asking for the maximum or minimum value. In other words, if I only look at part of the graph, not the entire graph, can I determine where the highest point is and where the lowest point is? And the answer is yeah. It's either at one of your critical points or it's at one of your endpoints. So you had to find the critical points and then make a regular chart table with those critical points and your endpoints in the table, and then put values back into the original function so that you can figure out the corresponding y's that would give you that maximum value or minimum value. Sometimes they were at the endpoints, sometimes they were at the critical points. It just depended on the graph. Last section we talked about concavity, concave, where it's concave up, happy face, where it's concave down, sad face. And we talked about that via the second derivative. Concavity comes from the second derivative. And we also discussed points of inflection. So I find the second derivative, set it equal to 0, and then make a sign chart out of that. This is concave down from negative infinity to 1 and concave up from 1 to infinity. If it changes signs, negative to positive, positive to negative, it is considered a point of inflection. If this were positive, positive, that would not be a point of inflection. And so that was pretty much your 5.6. 5.7 now, we're going to get into, is what's called the second derivative test, and it has to do with this concavity. If I am concave down, I am a frowny face, but I create a maximum situation. There's a maximum value. I have a hill. Where if I'm concave up, smiley face, I am creating a minimum value at that place. So it's giving you an alternate way to find maximums and minimums. You could use the first derivative test back from 5.4. You could use the second derivative test. It's an alternate way to be able to find a maximum or minimum. And that's what we're going to talk about today. All right, here it is, section 5.7. Identify the relative extrema. Well, the relative extrema for this would be this place right here, maximums and minimums, right? This is the original function. So this would be a maximum, a relative, I'll put relative max. This would be a relative min. What do we notice about the value of the derivative at each of the extrema? So in other words, what does f prime of x equal at that location? Think of your slopes, right? The slope of the tangent line. And we know this just from how do you find a maximum or minimum? You take the first derivative and you set it equal to 0. There it is. So we would say, what do we know about the value of the derivative at each of the extrema? We would say that that derivative equals 0. What do we know about the value of the second derivative at each extrema. So if I look at this extrema right here, he is part of a concave down situation. That means the second derivative, until we get to, let me change my color here, until I get to right here, about that location or so, this whole thing is going to be concave at this maximum, where the maximum happens. My second derivative is concave down, therefore it's less than 0 at your maximum. I guess I should say relative maximum. And then I know that my second derivative is concave up from there on, creating a minimum over here. So my second derivative is greater than 0, it's positive, concave up, at my relative min. And so then they say, okay, well, let's put it in a box, second derivative test. If the second derivative is positive, then your function has a relative minimum, concave up, looks like this, happy face. His eyes are a little out of whack, but you get the idea. And concave down if I have a second derivative that's less than 0. Oh, so unhappy. So here's what it says. It says, okay, use the second derivative test to find the relative extrema. Yes, I know, you can find it using the first derivative. That's not what they're asking you to do, though. They're asking you to use the second derivative to deal with it. So I'm going to find the second derivative. F of x was x to the fourth minus 2x squared. So I have a 4x cubed minus 4x. But I want to know what my second derivative is. So I'm going to come over here. All right, so second derivative is, take the derivative of this, 12x squared minus 4. All right, so let's think about this for a minute. If I have a second derivative and I'm trying to find a maximum or a minimum, then I need to know where those critical points are, right? Because that's where the maximums and minimums happen. So I got to go back to my first derivative and I need to set it equal to 0 so I know what values I'm going to evaluate into the second derivative. Got to find critical points first. So here it goes. 4x gives me x squared minus 1. Take that out. If I solve that, oh, I've got all sorts of things. 4x equals 0, x is 0. X squared minus 1 equals 0 gives me x is plus or minus 1. Those are all the possible places. By the way, is this undefined ever? And it's not. So I don't have to worry about the critical points for it being undefined. What I need to do, though, is take these possible points that could have maximums or minimums. If I was asked to use the first derivative test, I would just go ahead and make a sign chart out of that, but that's not where they're at. They want me to use a second derivative. So I have to find f double prime of each of these things. What's it doing at -1? What's it doing at 0? What's it doing at +1? And all I really care about is if it comes out to be positive or negative, because remember, I'm looking for, is it concave up or is it concave down? So if I put a -1, now I'm putting it into the second derivative. -1 in here gives me a positive out. 0 in here gives me a negative out, gives me a -4. Putting 1 in here, I'm back to a +8. And so I can tell from that that this is concave up at -1. So if it's concave up, smiley face, so I have a minimum at x equals -1. This one's concave down, so I have a maximum at x equals 0. And then I have positive again, concave up. Concave up's a smiley face, so I have a minimum at x equals 1. So that's how you use the second derivative test to be able to calculate these extrema values. All right, let's try another. Use the second derivative test to find the relative extrema for this guy on the interval from 0 to 2 pi. All right, so where would I have possible maximums and minimums for the function? They would be at the critical points. Find the first derivative. Square root of 2 is just a coefficient. So if I take that square root of 2x, it's just a square root of 2. If I take the derivative of negative 2 cosine, derivative of cosine is negative sine. That makes it a plus 2 sine of x. All right, I need to set that equal to 0 to figure out the critical points. Let me do that. If I set it equal to 0, then I swing this square root of 2 over. That gives me a negative square root of 2. When I divide by 2, now I'm at the sine of x equals negative square root of 2 over 2. I go around the unit circle and I figure out where is my y value, a negative square root of 2 over 2, and that would be at x equals 5 pi over 4 and x equals 7 pi over 4. So I say, okay, well, let me then figure out what the second derivative is and plug these x values in to my function. So if I do that, I have, let's see, second derivative for this. This derivative of square root of 2 is nothing, it's a constant. So I really only want the derivative of 2 sine of x. That would be a 2 cosine of x. And that's it. So I want to know what f double prime of 5 pi over 4 is, and f double prime of 7 pi over 4. Now notice they didn't ask me, they did give me endpoints, right? But they did not ask me for the value, for the relative extreme values. So I'm only looking for relative maximums and minimums. I don't need to test the endpoints for this. So if I put a 5 pi over 4 in here, I would have a 2 times the cosine at 5 pi over 4 is a negative square root of 2 over 2, so that's a negative. If I put in 7 pi over 4, then I end up grabbing out, put in a 7 pi over 4, it's going to be a positive. The x value is positive. And so I know from this that this is concave down, and that means I have a concave down is a maximum at 5 pi over 4. This was concave up, so I have a minimum at x equals 7 pi over 4. Okay, a little bit left here. If there is only one critical point, and that critical point is an extrema, a max or min, then it is an absolute max or min, not just relative. So here's the last one. I think this is the last of the examples. I have negative x e to the x over 4. And they want me to determine if I have a maximum or minimum, where the relative extreme are. So I'm going to do the same thing I did in the numbers 1 and 2. Find the first derivative. All right, this one is a product rule. Negative x times e to the x over 4 times the derivative of x over 4, which is 1/4, plus e to the x over 4 times derivative of negative x is negative 1. Let's see what we got going on here. I know I'm going to have to set it equal to 0. And I know both of them have an e to the x over 4. That leaves me with a negative 1/4 x minus 1. So e to the x over 4 has to be 0, or negative 1/4 x minus 1 has to be 0. So if I'm thinking e to the 4th, you may not, like, you're thinking e to the x over 4, I have no idea if that equals 1, but think of it as the graph. It's an exponential graph that's growing. Any kind of exponential graph rides along the x-axis as its horizontal asymptote, never crosses over. and it keeps getting larger and larger and larger. So this one can't equal 0. It asymptotes at 0, so it's not going to touch it. But this side I can actually solve. So negative 1/4 x equals 1. Multiply both sides by a negative 4, and I get x equals negative 4. Well, I want to know what the second derivative is doing. That's what this section's all about. So I can figure out what kind of extrema it is. So I want to know the second derivative, but ultimately I'm going to want to know what it is for negative 4. But let's go second derivativing here. Oh, lordy. I think the easiest thing would be to product rule this. So let's product rule it. First, times the derivative of the second, which is just a negative 1/4, plus the second times the derivative of the first, so e to the x over 4 times 1/4. Ooh, just fit that in there. Do I need to simplify that out? I don't know. I can put the 4 in, let's see. Ultimately, I want to know what's f double prime of negative 4. So e to the negative 4 over 4 is negative 1 times negative 1/4 plus negative 4 times 1/4 is positive 1 minus 1. E, and I don't even care about the rest of this because if you think about it, if this is 0, then the whole thing zeroes out. So what I have is this beginning term, because the second part, this becomes 0, which means that whole term zeroes out. This becomes a fraction that's negative 1 over e with a 4 in front. Now e is a number that is represented by 2.718, so it's going to be a negative over a positive, which means this whole thing is a negative, which means it is concave down, right? My second derivative is negative, so I'm concave down, which means if I'm concave down, I am a sad face, so I'm increasing then decreasing, creates a maximum at x equals negative 4. Now the whole thing he wrote about right here is because you have one critical point, and that one critical point is your maximum. If that one critical point is your maximum, it's no longer just the relative maximum, it's the absolute maximum, because he's the only guy. He's the only one. And there you go. They are the examples for this section. Let me pick a couple from our practice problems to look at, and then we will call it a day. So, first one I want to look at. I know how much y'all love the trig function, so let's go for number 3. Question says, find the relative extrema by using the second derivative test. So, I need to go first derivativing to find the critical points. First derivative is 1 plus 2 sine of x makes it 2 cosine of x. I set it equal to 0. I solve for my angle. So it's going to be a negative 1 equals 2 cosine of x. Divide by 2. Negative 1/2 is the cosine of x. Go around your unit circle. Think about where your x value is negative 1/2. And you will get 2 pi over 3 and 4 pi over 3. All right, x value is negative 1/2. Now they're the values you're going to put into your second derivative to determine if you have maximums or minimums. So now I got a second derivative. Second derivative would be 0, 2, negative sine of x. So negative 2 sine of x. I don't have to set that equal to 0. I just want to know what g double prime of 2 pi over 3 is, and g double prime of 4 pi over 3. And I don't care what the actual value is, I just care if it's positive or negative. So 2 pi over 3 If I go around the circle and I think about what the sign is, the y value is, when I then times it by a -2, I am at a negative. Because my y values this will be in the second quadrant, my y values are all positive. Positive times negative is negative. If I swing into the third quadrant, now my y values are negative, so negative times negative makes this positive. And so the question says, find the relative extrema. If I'm negative, I'm concave down, so I have a maximum, so I have a relative maximum, you can just say maximum, at x equals 2 pi over 3. If I have to give a justification, I would say because the second derivative is negative, or that it's concave down, and I would say I have a relative minimum at x equals 4 pi over 3 because my second derivative is positive. There it is. All right, let's see what else. I am looking at your test prep problems. The only thing that I would say to you is when you look at all of these are the same thing, like the same points of inflection, concavity, second derivative test, maximums, minimums. Until you get to number 7, they tried to trick you on number 7. Don't let them get you. Look at what they're asking you for. They're asking you now for the maximum value. The maximum value of the derivative. So now you're going to derivative it and have to work from there. So this is the one where you're making a table of values and putting it back into the original function so you can see where the tallest y value is or the smallest y value. In this case, they want the tallest. So watch the word value in the midst of that. All right, that's it. Give me an email if you have any questions, and I will see you in class.